Hi, welcome to week 4. We're going to talk today about reaching and maintaining a healthy weight. This is Professor Clemens, and I am your contemporary health issues instructor. So today, I think there's no argument that we are in an obese nation. And actually, there is an environment that's conducive for that, and it's called obesogenic. Obesogenic refers to an environment that promotes gaining weight and one that is not conducive to weight loss. I think we can all agree that our society is definitely, our environment's definitely not conducive to losing weight. There are so many unhealthy choices on practically every corner, and we're in such a fast-paced society, and there's also other contributing factors that our environment just doesn't help us be able to stay at a healthy weight easily. So we're going to talk about some of the factors that are involved in maintaining a healthy weight. So here's some statistics for you. More than 68% of American adults are either overweight or obese. And out of that 68%, 35% are actually obese. I want to go ahead and play this YouTube video and then we'll talk about it.
What are you hoping he weighs today?
I'm hoping he's actually lost at least a pound or 2. I'm hoping today.
Jalen?
Come on, that's us.
You ready to come in here?
That's us. Come
on. Okay, buddy. How to come stand right on the scale?
It's been a month since Jalen weighed in. He's been getting exercise, something Stacy hopes will work in his favor when he hits the scale.
Okay, you can have a seat right over here in the chair.
Sit.
He was 30 feet, 9.3 inches, and 101 pounds.
It's quite a bit more than last time, huh?
Yeah, that's not good.
Is this the first time he's been over 100 pounds?
Yes, it is. I'm very disappointed. I mean, there's got to be more that we can do. That's a dangerous weight for a 4-year-old.
See how tall you are.
For a boy his age and height, Jalen should weigh about 50 pounds. At 101 pounds, he's twice as heavy as doctors recommend. While it's hard news for Stacy, Jalen is just too young to take it in. He only knows that he's hungry.
You were already... No, because you're over 100 pounds. No.
Please.
No.
Please.
No.
Please, Mama. Please, Mama. Mama, please.
No, Jalen.
Please, Mama.
It's a familiar routine, one that ends the way it usually does, with Stacy giving in.
I'll let you hold it. Don't eat anymore, Jalen. No, I'm not laughing.
Stacy is at the end of her rope, but doctors here have developed a multidisciplinary approach to address the causes and effects of Jalen's extra pounds. Mother and son see a tag team of specialists, a dietitian, a physical therapist, even a resident in psychology.
It's been getting harder to say no to him because he's constantly pleading with me and pleading with me and pleading with me all the time. And that's the hard part, just having to say no. I can say no and he's going to still ask.
So in those instances when Jalen is profusely begging, what should she do?
She needs to ignore him, and we've talked about this, and
Each team member drives home the same message. For Jalen to lose weight, Stacy has to hold firm and learn to say no.
I talked to the nutritionist, physical therapist, and the psychologist before coming in.
His primary care physician, Dr. Razak, has the toughest message.
I know it's not going to be easy hearing this, but I have to tell you this. I can't sugarcoat this.
Yeah.
He's in the obese category, and that means if he does not make lifestyle changes, it's a guarantee that he will have the diseases like high blood pressure, diabetes, cholesterol problems, joint problems, depression, self-esteem issues, sleep issues. And I can go on and on and on.
But he's not there?
He's not there, but it's a guarantee. It's a ticking time bomb. It's not a matter of if it's going to happen. It's a matter of when. All I have to do is project this further, and this will end up here. By the time he's 20, he's going to be at least 500 pounds. But you know what? You're in the right place. We're going to get you all the help, all the support that you need, and we're gonna get him where he needs to be.
I just stepped out of the room so the doctor could examine Jalen a little more closely, and the doctor is just going down this list of diseases that Jalen is on the verge of developing, and I'm just watching Stacy, and I mean, I'm feeling so overwhelmed. I can't even imagine how this mother of this 4-year-old child is feeling. This is a life or death situation, and Stacy has got to draw the line now. 77% of obese children become obese adults. It's a preventable problem, but only if parents take action.
Where you at? Okay. I'm angry at myself because I let it get out of control. Jalen is my baby, and I love him just like I love all of them. And I want him healthy, and I'm willing to do any and everything to see that happen. I don't want to hurt him any more than I already have.
So as you can see from watching the video, obesity is not only affecting adults, but it's affecting our children too. Our children are more overweight now than they've ever been in the history of America. And you heard what the doctor said about all the different diseases, and the likelihood of him developing those diseases was 100% really by the time he was into his 20s. So we've got to figure out ways to manage this for sure. Okay, this was taken a few years ago. Let's see if we can expand this picture here a little bit. Anyway, this is according to state broken down. Okay, I think some of my picture might be cut off just a hair. But anyway, you can see the places that seem to be affected by obesity more than others. And it looks like in your southern states are really affected. The Midwest, really affected. If you happen to be on the West Coast, you're probably less likely to be obese, according to the statistics. That's kind of interesting looking around. We just made a recent move to Auburn, Alabama, which is the heart of the South. And the food here is absolutely delicious. Even at the fast food places, it tastes different. I don't know what they do here, but that's something that my husband and I have commented on, that we moved from Illinois to Alabama, and we can definitely tell a difference in the taste of the food. So I think they use a lot more fat here than they do other places, but in sugar. I mean, when they say sweet tea, they give a whole sweet tea. I need to put a little accent on there. There's a whole new definition of sweet tea here than there was in Illinois. I mean, I usually have to water mine down, and I like sweet tea, but this is crazy, the amount of sugar that they put in their sweet tea here. So I'm not surprised at all to see that these southern states it's more prevalent with obesity. Here's some more statistics in here that you could read through. No state had a prevalence of obesity less than 20%. 23 states had a prevalence of obesity between 25% and 30%. 18 states had a prevalence of obesity between 30% and 35%. 2 states, Mississippi and West Virginia, had a prevalence of obesity of 35% or greater. The South had the highest prevalence of obesity, 30.2%, followed by the Midwest, 30.1%, the Northeast, 26.5%, and the West, 24.9%. So what are those contributing factors? We talked about that in the introduction. There's probably lots of different things that contribute. You can just look at this. Obviously, fast food is huge. Not taking time to prepare our meals the way that maybe our moms and our grandparents used to prepare their meals. A lot of times it was fresh out of the garden. There wasn't all the chemicals added to the foods, and a lot of the chemicals will produce obesity or help that along for sure. Like, I remember reading something about a couple different brands of snacks, that there's they're actually adding a chemical in it that makes you crave more of it. I'm going to leave those brands out, but it was a popular brand of potato chips that said they actually had a chemical that made you crave more. So there's a bag of chips that you can't quite put down. It might not have anything to do with your self-control. It might have more to do with a fact that there is a physical substance in there that is making you crave it. So anyway, we consume lots and lots of sugar. You can just, just take a look at this. We are staying on the couch a lot more, whether, with the video games and social media, telephones, I know that my pastime when I was growing up after school is I, came in, put my stuff away, and got on my bicycle, and I rode that bicycle all over the neighborhood, and we would be out with the neighborhood children playing in the streets and ball and all kinds of stuff, and that was in the 70s. So, today it's different. I know that even with my own kids, a lot of times they're not out being active unless they're involved in a sport or that type of after school activity. They usually come home and turn on their video games or play on the apps on their phone, or just texting back and forth is huge. So we're just not as active as we used to be, in other words. And I guess you can probably think of many other things that would contribute right now to obesity. I think portion sizes, you can see that in the middle there. Our plates have actually gotten bigger over the years. And if you look at China, like older China, you'll notice the plates are a lot smaller. And if you were to go to get China today, you'll notice the plates are a lot bigger. So our portion sizes have definitely increased. And so sometimes we're not even that hungry. It's just that we feel like we need to eat everything that's on that plate. And so we do that. So let's look at some more contributory factors to obesity. We have our genes: body size and shape, body fat distribution, metabolic rate, the tendency to gain or not gain weight. Those are all can be found in the genes. And all of us can look around and see that we all have different body types. Some of us are big and taller. Our muscles, we have more muscle density. Maybe our bones are bigger, structure, taller, shorter. If you're a woman, you will definitely know and understand when I say some of us are apples, some of us are pears. And for those men out there that don't understand what that is, you can look that up on the internet. But a lot of times we are compared to shapes of fruit, and we just carry weight differently, and that's all in our genes. Some of us are predisposed just to be able to eat a lot. We have a high metabolic rate, and I am so jealous, or jelly is what my daughter would call it now, of those people out there that can just eat whatever they want and not gain weight. I am not one of those. In fact, I have a low metabolic rate, and I really have to eat less calories than a lot of people can in order not to gain weight or to stay healthy at a healthy body weight. We have the physiological factors. Hormones play a huge part. We just talked about metabolism, but hormones play a huge part. We have the women have different types of hormones, and depending on those hormones at different times of the month, those fluctuate, and that can cause us to want to eat more and to gain weight. Again, we talked about the fat cells distribution. Some of us have more fat cells than others. So this can all play a factor. Your environment, we just talked about that, so I'm not going to go into that like I did before. But we will touch on this as sedentary activities for kids. Just keeping in mind that that's a huge factor for childhood obesity. And then you have lifestyle. We in America love to party. We love to celebrate. We have an eating ritual for just about every holiday, birthday, anything you can think of. I know, especially being from the Midwest, we celebrate so much, and I love it. I love that time with our family, but it is always centered around food. And if you have a huge family, sometimes you're going to several birthday parties in one weekend or in one day. And so, usually bring out the feast when you have a birthday or a celebration. So you're not really eating healthy food necessarily. You're eating a lot of fat and sugar in those cakes. And again, the lack of physical activity just in all of our daily lives, because we're called to work more. We have more desk jobs, and those are all contributory factors to obesity. So it goes without saying that there are many health risks involved when you are obese. These are just a few of them. There are more than this. But cardiovascular disease, diabetes, cholesterol levels that are too high, hypertension, cancer, impaired immune function, gallbladder and kidney disease, skin problems, impotence, sleeping and breathing disorders, back pain, arthritis, bone and joint disorders, pregnancy complications, many, many health risks involved in carrying too much weight. Okay, here's those fruits that I talked on earlier, the body fat distribution and how men and women are different with where we carry our weight. You can just kind of read through those. That pear-shaped, more in the lower half. The apple shape is more in the upper half. And studies have shown that those people that have more of the apple-shaped are at a higher risk of high blood pressure, diabetes, heart disease, stroke, cancer. They have a higher mortality rate. So I find that interesting. So since we're talking about maintaining a healthy body weight, a lot of times we are so emphasize obesity and being overweight and kind of ignore the fact that you can also be underweight. People say, oh, I would love to be underweight, but not necessarily. It carries a lot of risks with being underweight as well. If you have too low of body fat, it can affect your reproductive, your circulatory, your immune system, and cause a lot of disorders in those areas. Now, women that don't have regular periods have a hard time getting pregnant. So if you have a low body fat, you cannot sustain a pregnancy. And so there's especially when that's a really major one with women that carry too low body fat. The muscle wasting and fatigue. When your body is not getting enough nutrients and the muscles need protein, when they are not getting enough of that nutrients, you can get muscle wasting, where basically it's just your muscles become weak and waste away, which can cause a lot of fatigue. It also not being a correct body weight or being too low in body weight can cause some heart problems. Obviously, if you are not eating enough to sustain life, you can die. This is a huge problem among female athletes. And I'm also going to put not only female athletes in here, but all actresses as well. Female actresses. Abnormal eating patterns, often coupled with excessive exercise patterns. Amenorrhea, which is the absence of a period. So they do not menstruate anymore because they don't have enough enough body fat to do that. And then a decreased bone density. So not only affects your muscles, like we were talking about, when you don't eat and get enough of your carbs and your proteins, and we do need fat. Fat has become such a bad word, but God made us and designed us that we do need a certain amount of fat. And if we don't get all those three nutrients, it can also cause a decrease in bone density, which can cause early osteoporosis. So this is your BMI chart, measuring your body mass index. This is a good calculation to find out if you have a healthy body fat compared to your muscle. And so you look at your height and your weight. So if you are 150 pounds and you are 5'4", you can kind of follow your fingers over to see what percentage range you should fall in. And that's going to tell you, are you underweight, are you healthy, overweight, obese, or extremely obese. So remember, you need to take these with a little bit of grain of sea salt, is what I call it. Depending on a lot of factors, you might you might be healthier and weigh a little bit more than someone else does and have a little bit less body fat. So I have a good friend of mine that is in the military and who is 6'4" and weighs 260 pounds. And if I were to follow that over, he definitely would probably be in that obese or extremely obese category. You can't see on this chart here. And that's been very frustrating for him because he really is only 12% body fat. He is just all muscle, and obviously his profession and what he's chosen to do, he works out a lot. So, yeah, obviously you've got to take a lot of factors into consideration, but this is a good range to look at. And there's lots of different ways that you can measure your body mass index. There's apps out there. There's bioelectrical impedance, which are scales that you can stand on, or a scale that you can hold that will measure your BMI. And there is skin calibers and that type of thing that personal trainers use. But if you want to kind of find your weight and your height, follow it over, look what that healthy range would be, and just so you're aware of that. So here's a body fat chart according to percentage and age and where you should fall. So you can see that the healthy range is around 20 to 30%, right around there, depending on how old you are. That's going to give you pretty much a healthy range, staying right in that percentage. Anything below 10% can cause problems. Anything above that 34% is going to cause problems as well. So I touch on this a little bit in my devotional and in the introduction for today, so don't miss that. But a lot of people go to these drastic measures to lose weight. I mean, obviously, most of us do it because of appearance-wise. We just don't like the way we look and we're really fed up with it. But there's other people that are so scared and have already developed some of these disorders. They're tired of being overweight. So there's some drastic measures that can be taken. Obviously, very low-calorie diets have to be supervised medically, but they come with risks. And there's some risks right there. You can reach sugar imbalances, decreased BMR, heart irregularities, loss of lean body tissue, etc. We also have quite a few drug treatments out there. I think every single year they come out with something different, it seems like, on the market. Although, keep in mind, the FDA does have to approve these drugs. So when they do come out, they have lots of research behind them to back them up. But the over-the-counter ones, OTC, they're not FDA regulated. So we've got to be really careful what we're buying even at the health food stores. Can cause a lot of side effects. And typically speaking, you know, after they come out within a couple years, some research comes out and tells us that they were ineffective, or they caused some other types of side effects or disorders. So it wasn't worth using the drugs in the first place. And then there's the surgery. And there's gastric bypass. We know several celebrities that have gone that route. And their stomachs can only hold so much food. So therefore, they're never at that risk of overeating. But that can also cause problems, and you can read those there too. So again, touch base in my devotional, and you'll get a little bit more insight of how I feel about that. But I do believe there's probably times that we have to take those drastic measures, but those are few and far between. I think God is a God of balance, and so we really need to seek to take the correct measures in a balanced way of looking at losing weight instead of going to the extremes. Let's take a look at this video about the mathematics of weight loss.
Right, well, I might get myself into a position here and on the red carpet. I don't think I need to introduce myself, do I? But this is the last talk for the day. We will have a little bit of wrap-up after this, and we will have a little time to reflect and maybe some questions. I know some of you will want to get home, but let's get cracking because we've got about, well, probably 12 minutes is my talk. Maybe it might go for 15, so don't panic if that thing goes over. So, here we go, the mathematics of weight loss. Well, let me start with this. Last year, I went surfing in Fiji, and the resort had a photographer following us around taking all these photos, which was really great, except that I couldn't help but notice this. Somehow, I'd managed to become 5 kilograms overweight. Couldn't believe my eyes. So I did what they tell you to do. I ate less and I moved more. And within just 3 months, I discovered I'd lost 6 kilograms. So then I did what a normal person does. I did physics, but anyone would do this. I graphed my weight. And when I did the linear regression, I discovered that, lo and behold, on average, I'd been losing 85 grams a day. Which got me thinking, in fact, it got me very curious about this question that I've since discovered most people have no clue about. In fact, they've never even thought about this. And to prove my point, I made a little video on Bondi Beach. And the question was this. When somebody loses weight, where does it go? What does it become? How does it get out of your body? You're probably dumbstruck by the question. These people were, so listen to this. Where does it go? Where does the weight go?
Where does it go? Well, I don't know. I don't know.
That I don't know. I don't have an answer for that. This is the mysteries of science. I have no idea.
Oh, I'd like to say into the ether. Into the ether. Ether? It gets used up. The universe
Another dimension.
doesn't go anywhere.
When she loses it, it comes over to me.
Becomes nothing.
Doesn't exist anymore.
I guess. That's a very good question. Good question.
What a fascinating question. What would you say?
It goes right in the crapper, mate.
Sweat. Moisture. And sweat. Evaporates.
Evaporate.
To their ass.
No, his poof.
Ends up at Bondi Beach.
That's where it goes.
Well, basically, you burn it up as energy.
Burn it as energy?
Heat energy.
Burnt.
In energy.
Burn it as energy?
Heat. Oh.
Don't know. Yeah.
You got me there.
I'm not quite sure.
So what the heck is going on? We're in the middle of an obesity epidemic. I don't need to tell you about it. So why don't these people know the answer to this fundamental question? Because not one of them was right, and we do know the answer. This is not groundbreaking stuff I'm about to tell you. So let me just remind you of a few things you do know. What's the chemical formula for water? H2O. Chemical formula for carbon dioxide? You all know it. Right, so you know what human fat is made of. So what is the chemical formula for human fat? There is such a thing, believe it or not. It's been known since the 60s. It's C55H1O4O6. That's the chemical formula for the average fat molecule in a human body. Some of the molecules might have a few more carbon atoms and a few more hydrogens. Some might have less. They all have just 6 oxygen atoms. That's very important and helpful for later. But this is the average fat molecule, C55H1O4O6. So let's be very clear about this. The difference between that and that is C55H1O4O6. I kid you not. And the difference between that and that, same thing, C55H1O4O6. So how does this stuff get out of a human body? Well, here's the general equation. Looks pretty sort of interesting, slightly complicated. Not if you've done some year 10 chemistry, surely. This is year 10 chemistry, although, well, it's not really, but here's what it says. Fat plus oxygen gives you carbon dioxide and water. That's what it becomes. And this biochemists have known this for ages. You inhale that, you exhale that, that's what happens to it. Amazing. Now, that little arrow there is kind of oversimplifying something called biochemistry. That's 3 years at university. And my apologies to the biochemists. I don't mean to oversimplify, but I'm trying to get to the crunch. It's really complicated. It doesn't just come out of you for no reason. You've got to do stuff. Eat less, move more. We'll come to that in a minute. But look, when you want to lose weight, you want to lose kilograms. That's all kilograms, all that stuff there. So why do people say heat? It burns up as energy, because that's what we've been telling them all this time. And it's very confusing because energy has different units, kilojoules, or you might use calories. And yes, that's heat. That's motion, when you move, or it's thinking. Your brain needs energy, or it's growing. But that's not where the fat goes. So what are we talking about here? Well, let me just show you a couple more things. So I've got some carbon dioxide here in its frozen form. We call it dry ice. It's carbon dioxide. It has mass. Thing is, you're not used to seeing it. But here's some dry ice. And it's heavy. And if you put it in water, lo and behold, it does this cool thing and bubbles. Like, you've all seen that before. Well, that's carbon dioxide and water. That's what fat is kind of made out of. But it's not fat. I'm not making fat. That is not fat. So how does that become fat? Well, it doesn't just like that. It becomes sugar first. Plants make fat. Well, they start the whole thing. A plant takes 6 molecules of carbon dioxide and 6 molecules of water, uses an amazing chemical called chlorophyll, holds them together, and then sunlight comes in and it binds those molecules together, and it becomes sugar. C6H12O6 is glucose. Fructose, same formula, C6H12O6. Sucrose is glucose plus fructose stuck together minus some H2O molecules, so it's, do the maths, C12H22O5. Right, well, here's some. This is sucrose. Plants make it. And it's this stuff joined together. It's now got chemical energy holding these molecules together so they don't just fly around like that. And by the way, if you drink that, 600 ml of lemon-flavoured soft drink, you'll get 17 teaspoons of this stuff are in there. I'll just quickly show you what that looks like. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Right. So if you drink that, it's the equivalent of doing what I just did with the spoon, except munching it all down. Exactly the same, no difference. So if you do that, then what happens? Well, let me explain something else that I've been telling kids for a little while, and they get this. So when you eat food, it's not in your body straight away. If you swallow that sugar, it's not in you yet. So here's a pool noodle, right? It's got a hole running through it, and here's an almond. And if I put the almond in there, it can go all the way through and out the other end. Whoop-de-doo. Here's another almond. If I put an almond in here, where's the almond? You would say the almond's in the pool noodle. Okay, but is it in the foam that the pool noodle is made of? No, of course not. It's just in the hole that runs through it. That's food. You swallow food, it's not in you. It's in the hole that runs from here to the back door. And getting food into you is called digestion. So with this stuff, you've got to break the bond that's holding the fructose to the glucose. And as soon as you do that, then that stuff can cross the barrier, your internal skin, and into your body, and then it can go around in your blood. That's digestion. But now it's not metabolism yet. It's got to go into your cells, and then you've got to burn it up. And if you don't burn it up, if you eat all that sugar after you've had your 3 meals in the day, your body doesn't waste it. It doesn't come out here. The stuff that comes out the back door was never in you. Apart from a few molecules of cholesterol, it's just fibre that you couldn't digest, plus the bacteria that live in your gut. You lose about 500 billion of those in one single sitting. They're tiny. That's many times the population of the Earth every time you flush the toilet. It's amazing. But that stuff was never really in you. So here's what happens. If you don't then metabolize that sugar, well, then it's going to get converted into the stuff that we all have a problem with, fat. Now, better just prove that you do breathe this stuff out, right? If you metabolize sugar, you turn it back into carbon dioxide and water. So every time you exhale, out comes a bit of carbon dioxide. You can't see it. This is the problem. This is why people don't know how you lose weight. So there you go. I've trapped some breath. I've inhaled that. 5% of the air in there is now carbon dioxide because it's come out of my lungs. I've got some liquid nitrogen here, and I'm going to use that to freeze this air. Liquid nitrogen is minus 196, very handy. Where did I? It's right there. In fact, I'll just pour it straight on. So be a little bit careful with this stuff. I use it all the time. If I look a little blasé, I don't mean to. Please respect this stuff if you play with it the way you would respect boiling hot water. Now, if you pour it onto a balloon, the balloon does not pop, which is incredible. The nitrogen's minus 196. Oxygen turns into a liquid at minus 183. So the oxygen in the balloon is turning into liquid. Carbon dioxide turns solid. I've got a big bowl of it there. But it turns solid at minus 78. So in the balloon now, I have I have liquefied oxygen and frozen carbon dioxide. And when I take it out, you'll see them. So, it'll just take a while for the balloon to go a little bit clear at the top. The nitrogen in here, air is 79% nitrogen. The nitrogen is in the top of the balloon. But now, look at that liquid down there. Can you see that? That's the oxygen from my breath that I hadn't used. But once it's all gone, there'll be some white powder left. Right, the white powder is breakfast. That's the carbon dioxide, the carbon atoms I ate in the last 24 hours. And when I blow on them, they get warm enough to turn back into gas, and they vanish, and people think there's nothing in the balloon. The balloon has mass. Those atoms have mass. You can see carbon dioxide has mass when you solidify it, but when you breathe it out, you don't see it. And we've been confusing people by talking about kilojoules or calories, and they're really important. But people do not seem to understand that when you lose weight, you're losing atoms. You can't just turn atoms into nothing. In fact, science teachers out there, you need to change the way you teach chemistry, because those people, and many in this room, think that you can turn atoms into energy. Well, it's one of the founding principles of modern chemistry. You cannot turn an atom into pure energy. It's called the conservation of mass. Before a reaction and after a reaction, we teach kids you've got to have the same number of atoms. It's called stoichiometry. Well, we haven't been teaching it very well at all, because people think you can turn fat, which is kilograms, into nothing, or just kilojoules. Can't do it. So here was my big fat question. I'm a physicist. I knew that bit. But my question was, if I've got 10 kilograms of this stuff, then how much carbon dioxide does that become? And how much water? And it turns out that that's really simple too. This is year 10 chemistry and year 10 maths. You need the periodic table of elements. You have to look up hydrogen, carbon, and oxygen. There they are. Now, the periodic table has some important information on it. The weight of a single atom of these elements. So the weight of a single atom of carbon is 0.11 atomic mass units. Doesn't matter what they are in kilograms just yet. I'll show you why in a minute. We've got 55 of those in an average fat molecule, so there's 660.59. Okay, great. What about the hydrogen? Okay, there's 104 of those. So we have, in one molecule of fat, 95.996 atomic mass units. The oxygen's a little trickier. This stumped me for quite some time. In fact, I rang around and I couldn't get a very clear answer on this, because it doesn't seem that many biochemists have thought about it this way. That's not because they're silly or whatever. They just haven't thought about it in this way, which really surprised me. Because this bit of information is the most motivating bit of information I had in my personal little journey of losing 17 kilograms in 6 months. It's all gone. Breathe it out. Amazing. Anyone can do this. It's not hard. So how much carbon dioxide and water? Well, the oxygen's important. There's 6 atoms of it in a molecule, but what are they going to become? Are they going to go out as carbon dioxide, or are they going to go as water, or are they going some ratio of the two? How do you figure this out? It took me ages, and then the answer turned up in a very old paper from the 1940s, where they'd taken water, labelled the oxygen atoms, made them put an isotope of oxygen onto those, and oxygen 18, gave it to mice. The mice had it go in their belly, but then it came out in their breath. So water had the oxygen in it, but then that oxygen turned up in the exhaled breath, which showed that oxygen atoms are exchanged between carbon dioxide molecules and water molecules. There's a really good reason for that. Here's some phenolphthalein in water. It's a bit hard to pronounce. It's gone a bit murky because I've left it sit, but look, if you blow in here, changes colour. Great, whoop-de-doo. What does it show you? It shows you that carbon dioxide dissolves in water, forms carbonic acid. There's an exchange of oxygen atoms. So what this told me is that the way these 6 atoms are going to leave your body is in the same ratio that they exist in the molecule. So that's at 2-to-1 ratio. So that means 4 will go out as carbon dioxide and 2 will go out as water. That's great. Now I know the answer. So now you do the maths. So we've got the first 2 answers. I'm going to add to the carbons the weight of 4 of these oxygen atoms. They're going to go out with carbon. So I'll chuck that up there, and I've got 2 to go. So 2 times that, there we go, chuck that with the hydrogens, because they're going to go out with some hydrogen. And now I can figure out the ratio of carbon dioxide and water from my fat. So there's the totals, and now we've just got to divide it by the total, and you get 84% will go out as carbon dioxide and 16% will go out as water. So here's the answer then to my big fat question. 84% of fat is exhaled, 16% is excreted as water somehow. It can be in your urine, in your feces, sweat. That means that 10 kilograms of fat becomes 8.4 kilograms of invisible gas that you breathe out. That's amazing. Every time you're doing some exercise and your breathing rate goes up, you're losing more weight than when you're sitting down and not breathing as rapidly. And 1.6 kilograms will come out as water. Now, we don't know if that comes out in your poo or in your wee or in your sweat or in your tears because you cry a lot. Who knows? But now I've got some frequently asked questions that I need to answer because there's lots of them. Well, there's 3 main ones. 1, can I just sit around and breathe more? Everyone asks me straight away. Well, you can sit around and breathe more, but it's called hyperventilation. You've got to coax the C55H1O406 out of the fat cells. They're called adipocytes. And to do it, biochemistry, mate, it's amazing what really goes on. It's a long story, but you need to get them out by, first of all, moving more or eating less. You've got to sort of starve yourself of energy so that you start turning these big molecules of fat. They get broken into 3 fatty acids each. They're called a triglyceride, but they have to be broken apart before they can come out of the cells, the hidey holes that they live in your bingo wings or your double chins or your butts or your muffin tops or wherever it is. It's hanging around in there. It's not going to come out until this hormone breaks them apart into its fatty acids. It goes into your bloodstream, and then you can oxidize them. Beta oxidation, big long story, really complicated. Amazing that we know it. But FAQ number 2 is, does weight loss cause climate change? Well, this is another really disturbing little thing because it means people don't understand climate change. They just don't. Because if you did, you wouldn't even think that. But people think, so why doesn't it cause climate change? Because food was made by plants just in the last couple of years. And the way it did it was it took sunlight and glued water to carbon dioxide. When you eat, you're actually, the energy is sunlight. It was put there by the sun. If I wasn't, well, I'm not a hippie, but I just about am because I think that this is amazing. You eat sunlight. That's the energy that you get. But it's modern sunlight. When you burn fossil fuels, that's ancient sunlight. It's locked up in the ground as carbon in wood, dead wood, ancient fossilized coal. And oil is ancient, dead, fossilized critters that lived in the sea, that photosynthesized, that died, that got buried, that eventually turned into oil. This does not cause climate change. And the fact that people don't know that means we need to teach them more about climate change. No wonder there are so many myths about both these things. There are myths about weight loss. There are so many diet gurus out there. Mate, if they didn't know this, are you going to trust anything else they have to say to you? No, hopefully not. Stop buying their books, their pills, their rubbish. Why did you not know this until today? I don't know the answer. But it certainly makes me very, very skeptical about any health claim that anyone makes who's supposedly a guru. The third question that I don't get asked, but I should get asked, that I don't get asked at all, except the biochemist would be sitting there wondering it right now, did you take into account ketosis? And no, not really. I did not. Ketosis is when you starve yourself of carbohydrates, when there's no glucose in your blood. And you can do this thing called ketogenesis. Your liver does it and can convert fat molecules into ketone bodies. Acetone is one of them. You go to a nail shop, get your nail polish removed, acetone, right? Your body makes that stuff. But you don't want to make it in huge quantities because you're going to acidosis. So I'm not going to comment on whether or not eating low protein diets is a good idea because I'm not an expert on that. I would say that I'd be careful because it's linked to depression apparently in some papers. I don't know. I'm not making any health claims about low protein diets. What I'm saying is that this is very simple. If you just do what I did and what lots and lots and lots of other people, I don't want to meddle. It's easy. All you have to do to lose weight is turn it into carbon dioxide and water. And to do that, all you have to do is eat less, move more, and keep breathing. Thank you.
So as you can see from that video, I mean, the bottom line is you've got to burn those calories. And obviously the best way to do that is to get moving and exercise. So, or just move more, basically. But managing your weight, use measurements as a guideline. Make sure you use standards by your doctor, or standards that have been researched well, not the latest fad. Don't focus on a particular number. That we always get caught up in that. You know, we want to be a certain amount of weight and we get discouraged if we don't hit that, and then it sends us into a tailspin and kind of really puts us back into the binge cycle again because we feel like it's hopeless. So I don't focus so much on a number, focus on the benefits, focus on what you're gaining from it, not weight, but the other benefits that you're gaining from losing weight. Instead of a weight on a scale, I like to tell my clients to focus on a size. So let's say they're a woman and they're a size, I don't know, let's say that they're a larger size and they want to get down to a size, everybody always says size 6 or whatever, and sometimes that's even unrealistic. But let's say that they start with a bigger size and they want to get down. Instead of focusing on the weight on the scale, focus on just getting to a lesser size. So if I'm a size 14 and I want to be a size 6, I don't go out and buy size 6 pants. I go out and buy size 12 pants. Just get some cheap pants at Walmart. Try on those pants as you lose weight. That will help motivate you. After you get the size 12, go to a size 10. And use smaller increments and more of a balanced increments as you begin to lose your weight. That was just one tip I give my clients. Focus on a healthy life, improve eating habits, understand calories and energy balance, which you just got a great scientific lesson on that. Include exercise, and again, remember all of this, and lots of this, comes back to the stress in your life, and people overeat to counteract stress. And so that's huge. So a lot of times if we can reduce the stress in our life, we don't turn to food to fill that void or comfort that we need during the stressful times.